This is Math 131, section 3.2. In this section, we're going to look at, kind of extend our discussion of symbolic logic and talk about truth tables. So a truth table is used to determine when a compound statement, that might be more than one statement combined, is true or false. Okay. So let's start with just one simple statement, P, whatever it might be. We have two cases for P. It could be true or it could be false. Okay, so think of each statement could be either true or false. We don't know for sure, so we test both. And then the negation of P is just the opposite. So if P is true in case 1, the negation of P is false. And then if P is false in case 2, then the negation of P is true. Okay, so the negation just changes it from true to false or from false to true. When we have two simple statements, it gets more complicated because we're going to have 4 different cases. Because we could have cases where both P and Q are true. We could have a case where P is true but Q is false, and vice versa. We could have a case where P is false and Q is true, and then we could have a case where they're both false. So whenever you have two compound statements, you're going to have 2 squared equals 4 different cases, okay, different scenarios, okay, because you're combining two things. It's kind of like our sets where we had 4 regions. Now when we have 2 simple statements, we're going to have 4 different cases: true, 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 false, false, true, or false, false. Okay, so let's first look at conjunction. Now remember, conjunction is and, so that would be P and Q. Okay, now that is true only when both P and Q are true. So if we say P and Q is true, that means they both are true. So the only time that P and Q is true is when both P and Q are true. So if we have a true, true, then P and Q is true. But if P is true and Q is false, then P and Q is false because they're not both true. And then if P is false and Q is true, case 3, then P and Q is also false because they both have to be true. And then case 4, when they're both false, well, they can't, neither one of them is true. So the only time it's true for P and Q conjunction is when they're both true. Okay, and disjunction is or, P or Q, and that is true when either P is true, Q is true, or they're both true. So in other words, we just need one of them to be true. Okay, so if we have one true, then P or Q is true. But if they're both true, it's true as well. So it just has to be one of them or both. Okay, so case 1, they're both true, so P or Q is true. Case 2, P is true, Q is false, so at least one of them is true, so P or Q is true. Case 3, P is false, Q is true, so at least one's true, so P or Q is true. And then the only time that P or Q is false is when they're both false, P and Q. So it's different than P and Q, right? Here we just need one of them to be true. For and, we need both of them to be true. Okay, so negation P is read as not P, that little squiggle. Sometimes I say squiggly P, but we can read it as not P. Okay, so if P is true, then negation P is false. Okay. If P is false, then negation P is true. Okay, so another way to say it is that negation P will always have the opposite truth value of P. Okay, just looking at conjunction again, P and Q is read P and Q. And P and Q is true only when both P and Q are true. Okay, so both of them have to be true. And then disjunction, P or Q is read P or Q. And P and Q is true when either P is true or Q is true, or both P and Q are true. Okay, so another simple way to say that is P or Q is false only when both P and Q are false. Okay, so it's kind of the opposite of the conjunction. So this is false only when both P and Q are false. Okay, when we construct truth tables, you don't have to do it this way, but this is kind of a shortcut way to do it. If we're doing the negation, we would put it the answer under this one if it's a negation. Okay, we put it under the and if it's a conjunction. So if we're actually doing the and, we would put it under the and sign. If we're doing the or, we'd put it under the or sign. There's a disjunction. Conditional we haven't talked about yet, but we put it underneath that. Biconditional, we put underneath that. Okay. We talked about that a little bit, but we'll get that into a little more detail in this section. Okay. Okay, so this is the first step in constructing a truth table. Okay. Okay, so when we construct truth tables, let's say we have simple statements P, Q, and R. Okay, and their negations. Okay, that would be not P, not negation Q, and not negation R. If there, and then within parentheses of present, so if there are nested parentheses, work with the innermost pair first. And by nested, I mean, let's say you have this. Let's say you have P and Q or R. Okay, we would do, oops, let me put the parentheses there on the outside as well. So we have that. Okay, we don't really need them there, but let's say we have parentheses here. These are the outer ones and these are the inner ones, so we're going to do the inner ones first. That's what we mean by nested, that we have pairs of parentheses inside pairs of parentheses. So we do Q or R first, then do P and. So we would do this thing first and then do P and whatever we got here. So this is our second step in completing the truth table. Complete the columns under the simple statements. Okay, our third step in constructing truth tables is complete the columns under the connective within the parentheses, if present. Okay, we'll talk about connectives. That would be like the or, the disjunction, or the and conjunction. Okay, so we use the truth values of the connective in determining the final answer in step 5. Okay, that would be our last step. Okay, step 4 in constructing truth tables is complete the column under any remaining statements in their negation. Okay, and then step 5 is complete the column under any remaining connectives. The answer will appear under the column determined in step 1. I'm not going to worry too much about knowing these steps, memorizing these steps. You'll see as we do these how by example. I think it's a little easier to see. These steps are not that constructive, so I think if we can learn by doing a bunch of these, and we'll do a bunch more in class. So let's look at an example first. Construct a truth table for negation of negation Q or P. Okay, so we're gonna have to find negation Q first, or not Q, and then or it with P. Okay, so do the disjunction with P, and then take the negation of that. Okay, so think about, we have to do the parentheses first, but we got to find this first because we're going to take this thing and or it with P. Okay, so the first thing we do is we look at the possible cases. Since we have two simple statements, we're going to have four lines or 4 cases. True, true for PQ. True, false. False, true, or false, false. Okay? And then the next step is, now the steps aren't really obvious here, but the first step would be to find the negation of Q. Okay? So if we look at Q, notice Q goes true, false, true, false. If we take the negation, it's going to go false, true, false, true. So we're going to change them all the opposite. So that's our first step. That's the step here. Okay. And then our second step is going to be just copy P over. So we're copying true, true, false, false over here. And then we're going to take the or of these two, the disjunction of these two. So when we take the disjunction, false or true would be true. Remember, just one of them has to be true. True or true would be true. Okay. False or false would be false. And true or false would be true. So the only thing that's false here is that case 3, where we're taking this or this. Okay, so we have to get these pieces first before we take the or. Okay. So that's step 3. Okay. And then finally, step 4 is our last step, which means we're going to take this thing in parentheses, which is this column, that third step, and just take the negation of it. So negate this. This is true, true, false, true. We just change it to false, false, true, false. So we negate all of these. Okay, and that's our final step. So this is kind of the shortcut way of doing that. There is a long way of doing that. That's a little more writing, but it's a little bit easier to see how we're doing the steps because I'm kind of showing each step separately. So this, you can do it the short way, you can do it the long way. I'll show the long way in class. Okay, so our truth table for this thing is going to be this column, and you notice that it's only true when P is false and Q is true. Now we did that by putting all the pieces together. Okay, let's look at another one, constructing a truth table for negation P and negation Q. Okay, so we start with our 4 cases. P is true, Q is false. P is true, Q is false. Sorry, P is true, Q is true. P is true, Q is false. P is false, Q is true. And then finally, P is false, Q is false. One way to construct this is to do your, think of like, for P, half of them are going to be true, half are going to be false. So just do 2 T's, 2 F's. And then we split them up here. So when we have 2 trues for P, we're going to have a true, false for Q. When we have true, falses for P, we're going to have a true, false for Q. So kind of, getting used to putting them in this order. True, 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 false, false, true, false, false. Okay, the next step is to find the negation of P. So P is true, true, false, false for each case. We're going to change it to false, false, true, true. And then take the negation of Q. So Q is true, false, true, false. So we make that false, true, false, true. And now we're going to take, I need to write this in here. This is negation P and negation Q. Okay, so that should be negation Q there. Okay, and so we take those 2 columns and we take the and of those 2. So negation P and negation Q. Now remember, that's only true when they're both true. So false, false gives us false. False, true gives us false. True, false gives us false. And then the only one that would give us true is the true, true. So this statement here, negation P and negation Q, is only true when both P and Q are false. Okay? Or when both negation P and negation Q are true. Okay, let's look at an example using a word problem. Determine the truth value for each simple statement, then using these truth values, determine the truth value of the compound statement. So 1 million is greater than or equal to 1 billion. Okay. Now we're going to say, use statements that are affirmative for our simple statements. We'll never use a not in our simple statements because the negation will be the not. So make sure your simple statements are always affirmative. In this case, it's pretty obvious. Okay, but maybe coming up with these statements is not obvious. So let's make P 1 million is greater than 1 billion. Okay. And then Q is 1 million is equal to 1 billion. Okay. And then we're looking at the compound statement can be expressed as P or Q. So we're going to look at P or Q. Because our statement, remember, says 1 million is greater than or equal to 1 billion. So this is when it's greater than, and this is when it's equal to, and we're saying it's one or the other. Okay. Now, notice both P and Q are false. Okay. So, we know that P is false, right? 1 million is greater than 1 billion. No, that's not true, so that's false. Okay. And then 1 million is equal to 1 billion. No, that's false. So what we have here is a false or false. Okay, I'm looking at the truth value of this thing, P or Q. And we have false or false. So our result is false. Our result is false. Okay. So that's a false statement. But we're using it. I mean, it may seem obvious. Yeah, obviously 1 million is not greater than or equal to 1 billion. But we have to translate this into statements with symbolic logic to show the truth value for cases like this. And here's where it can get more complicated. Okay, so for this example, determine the truth value for each simple statement, then using these truth values, determine the truth value of the compound statement. Okay, so we have Angelina Jolie is an actress, or Zac Efron is a janitor, but Johnny Depp is not a plumber. This book is a little bit old, so might have cultural references might be a little bit dated, but we know who these people are, right? So we have to come up with some statements. Maybe one of them would be Angelina Jolie is an actress. Okay. The other set, we call that P. Q, we could say is Zac Efron is a janitor. Okay. But for R, we're not going to say Johnny Depp is not a plumber. We're going to say R would be Johnny Depp is a plumber, and this would be negation R. So don't always make your simple statements affirmative. So if you have a not there, that's going to be a negation of a simple statement. Okay, so here's our statements. P being Angelina Jolie is an actress. Q being Zac Efron is a janitor. And R being Johnny Depp is a plumber. Okay. And then what we're looking for is P or Q, parentheses, negation R. Okay, and the reason for that is because our statement said Angelina Jolie is an actress or Zac Efron is a plumber or is a janitor, comma, but Johnny Depp is not a plumber. So the comma tells us where to put our parentheses. So you can kind of think of this. You can kind of mark it off, like put your parentheses around where the comma is. Okay. So this is what we group together, is this statement here. This first part gets grouped together. And then the rest of it gets put afterwards. Okay, so we're going to put parentheses around this part. So we have Angelina Jolie as an actress, so P or Q. So or is Efron is a janitor, so or Q. And now remember, but is the same as and. So but and mean the same thing. So but and Johnny Depp is not a plumber, so that's negation R, because remember our statement is Johnny Depp is a plumber. Okay, so that's how we translate that, is that you look for the comma. Remember the comma was, I kind of lost the comma there, but the comma was right here, right? So that tells you where to group things. Okay, so that means we're going to group this stuff together, parentheses, and then we put this, tack this stuff onto the outside. Okay, so there's our compound statement, P or Q, parentheses, and negation R. Okay, so let's look at the truth value of this. Now we know that P is true, right? So let's just look at the truth values for these before we move on. So this one's true. Zac Efron is a janitor? No, that's false. Okay. Johnny Depp is a plumber? No, that's false. Okay, so we know that, we know the truth values of these statements, so we can assign them for each one. So P is true, Q is false, and R is false. Okay. So we're going to have this. We're going to have true, true, or false. Now I'm assigning the truth values from P and Q. And now negation R would be true. So and true. Okay. So we're going to have this thing. So we'll analyze that on the next slide. Okay. So we have the statements P is true, Q is false, and R is false. Since R is false, negation R is true. Okay. So the statement is P or Q, parentheses, and negation R. P is true, Q is false, negation R is true. So we translate that. We have true for P, or Q false, parentheses, and negation R is true, so that becomes true. Okay. So we're going to do the parentheses first. True or false. Remember, just one of them has to be true for or, so that becomes true. So true or false is true. And true. So we have true and true, which means both of them have to be true in order for the statement to be, the compound statement to be true, and that is true and true gives us a true. So we can say the original compound statement is true. Now that might not be obvious looking at that. If we just read the statement, you might read that original statement and say, I don't know if it's true. But if we do the symbolic logic where we assign simple statements and then use our symbolic notation and then assign the truth values to everything and figure it all out, we can actually figure, it's pretty simple once we do that. And then we can say, well, this compound statement is true or it's false based on what we did. Okay? So we'll look at more examples in class where we're doing tables, and maybe we'll look at the steps where we kind of break out the steps more in detail rather than do it in the shorthand. But I'll show you both methods in class. So we'll look at that, and then we'll look at some of these statements as well.